In this video, we're going to look at algebra, review some of the practice questions that we have to understand. So as you can see, first of all, look at indices. We'll get to look at surds, and many more questions on surds. From there, we have more practice problems to look at, just under surds, then simultaneous equations. Okay, so let's start. So simplify the following expressions. So basically the rule is whenever you have two different powers, okay, so for you to simplify it, you just have to multiply the powers. So 6 times 1 over 3, which is just going to be x to the power what? So you can divide the 3 into the 6, it will be a 2. So you have x to the power 2. That's how you simplify. So the rule there is basically whenever you have something raised to a certain power, let's say a, then there is another power outside, you just have to multiply the 2 for you to simplify it. Okay, so moving to the second part of the question, we have root of 2, then we have x to the power 3 in brackets, then the other part we have division. So the moment you see division, we just want to make it multiplication, and if you do that, it becomes reciprocal, so you exchange the numerator and the denominator whenever you are. So the basic concept is if you have 1 over 2 being divided by 4 over 3, this is basically going to be 1 over 2 multiplied by, so you exchange these guys, so it will be 3 over what? A 4 there. So the same concept applies to what we have. So what we're going to have is, we'll have x squared over 32. Okay, so then we have the square root there. So another thing that we have to understand is whenever we're looking at the square roots, so when you have the root of, for example, 4 over 16, basically that is equivalent to the root of 4 over the root of 16. So meaning that you can distribute the square root. So the same applies to what we have. We can distribute our square roots to what we have. So we have root of 2, we have x to the power 3 multiplied by, so we have root of x squared over what? Root of 32. Okay, so I want to simplify it further, so I'll move to the right hand side. So we have root of 2 x to the power 3 multiplied by, so the root of x squared is, the x squared to cancel out with the root, so it just be x over what? The root of 32. So root of 32 is the same as 2 by what? By 16, the root of it. So we have root of 2 by 16. I think I can erase this to create some more space. Okay, so let me use a different color here so that you're not confused. So from there we now have root of 2. So whenever you have root of something, a by b, this is equivalent to root of a multiplied by root of b. So we can split that as well in such a case. So we have x over, so first of all we have root of 2, then root of 16. Okay, so from there we can move a bit. So we have root of 2 multiplied by x over, so root of 16 is a 4, so we have root of 2, then, so we can basically start with a constant, so we have a 4, then root of 2. So this has been simplified, that one has stood out the way it is. So at that point we know that we can multiply what we have. So remember this side, I've just omitted x to the power 3, supposed to be there, so I'll show it there. So this is going to divide, so we'll remain with the product of x to the power 3 by the x, which is going to be x to the power 4 over 4. So that's how you simplify that. Given that 125, so this is coming from indices as well. So write the first question of 125 root of 5 is equal to 5. So this was supposed to be the power a. So 5 to the power a. So find the value of a. How do you go about it? So basically these are indices. How do you get to approach them? So you want to be reminded of the indices laws that you know. So basically you have to know that whenever you have the same base, okay, If it is x, that is 2, it means that the value of x is equal to 2 whenever you have got the same what? The same bases there. Then the other concept that you have to understand is whenever you have the same bases being multiplied, let's say they are raised to the power 2 and 2, the result is basically going to be you add the powers 2 plus 2. And the other basic idea is when you are dividing, for example, to the power 4, then at the power 2. What you get to do in such a case, you subtract the powers 4 minus 2. So these are the laws that are going to help us simplify that we have in this case. Okay, so 125 is basically 5 to the power 3, meaning that you multiply 5 by itself 3 times to get to that. Then the root of 5 is the same as 5 to the power 1 over 2. So let's try to move on. So what we have is we have 5 to the power 3, which is 125, being multiplied by 5 to the power 1 over 2 is equal to 5 to the power a. So what are we multiplying? We're multiplying the same bases, so we can maintain the base. Then we said for multiplication you get to add the powers. So you have the addition of 3 plus 1 over 2 being equal to 5 to the power what? 5 to the power a. So the other law that we talked about is when you have the left and the right hand side with the same bases, meaning that the powers are supposed to be equivalent. So a is going to be equal to 3 plus 1 over 2. So you know how to add fractions. So the shortest way is by multiplying this with that. You have a 6 plus a 1, 7. So 7 over 2. That is your final answer for the first part of the question. So these are indices. Okay. As you could move to the second part of the question, you have 49. This time around we are dividing. It's 49 divided by the root of 7, being equivalent to 7. So that was supposed to be the power a as well. So we are also expected to find the value of a. So we want to make sure we have the left hand side being expressed in terms of 7. So 49 is the same as 7 squared. Root of 7 is the same as 7 to the power 1 over 2 equal to 7 to the power a. At that point, when we are dividing the same bases, you subtract the powers, so it will be 2 minus 1 over 2 being equal to 7 to the power a. So therefore we have the same bases there, so our a is going to be 2 minus 1 over 2. So I believe we understand how to subtract fractions. So 2 by 2 is a 4 minus a 1 is 3. So our a in this case is going to be 3 over 2. And we've solved both questions. So these are all coming from indices, basic algebra. Okay, so simplify root of 2. So I'll write that better so that you're able to follow. So root of 2 basically it's supposed to be divided by 2 root of 5 minus 3 root of 2. So we're expected to simplify this to the form a plus a root of b, meaning that it's more like we're just trying to rationalize the denominator. We don't want to have anything to be part of the denominator there. So how do we get to approach such a question? So it gets multiplied by what we call the conjugate. So the conjugate involves you changing the sign of the surds. So in this case, we look at the denominator. So if we change the sign, it's going to be 2 root of 5. I'll change the sign in between, it will become a positive. So the same is going to be done to the numerator. Okay, so there we are. So at that point, what approach do we get to use? So multiply now. Root of 2 by 2 root of 5. So there is a coefficient of 1. So 1 times 2 is a 2. I'll write that. Then root of 2 by root of 5. So we have root of 2 being multiplied by root of 5. And we understand that. Okay, so we'll show that in the next stage. Then again 1 times 3 there is a 3. Root of 2 times root of 2, I'll show that. Over, what do we have now? For the denominator, whenever you're multiplying the conjugate, you just multiply the like parts. So this times that, 2 times 2 is a 4. Then we have root of 5 multiplying by root of 5, minus 3 by 3 is a 9. Then root of 2 by root of 2. Okay. So now let me try to remind you some of the things that you have to understand whenever you're dealing with surds. Some of the rows and the sides that you're supposed to know is, whenever you're multiplying things like this, it's basically the same as combining them as a over b. a multiplied by b rather. Then whenever you have a root of a by root of a, so it's basically just going to be a, meaning that what you have is, because what you're saying is the square root is the same as the power 1 over 2. So from the rows of indices, what do we know? We know that you get to add the powers. So 1 over 2 plus 1 over 2 is just going to be at the power 1, which is just basically a. Okay, so these are going to help us simplify what we have in this case. So whether root of 2, root of 5, we can combine the 2 and it will become 2 times 5, which is going to be a 10. Then root of 2 times root of 2, it's basically a 2. So we have plus 3 and a 2 there, over. Then root of 5 by root of 5 is 5. So we have 4 over 5. 4 multiplied by 5 minus. Root of 2 by root of 2 is a 2. So we have 9 times 2. So we can simplify further. What can we have in such a case now? So 2 root of 10, then that is plus 6, over 4 by 5 is 20, 9 by 2 is 18. So this can simplify to 2 root of 10 plus 6. Then 20 minus 18 is a 2. So I want it to be in that form, so I can divide by the 2 throughout. Okay. So we can factorize the 2 on top. So we have a 2. Then you remain with the root of 10 plus a 3 over 2. So the 2 cancel out. And basically what you're going to remain with is just going to be what? You just have the solution being just root of 10. So starting with a, we can say 3 plus root of 10, which is basically in the form that the answer was required. Show that 4 divided by 2 root of 2 minus root of 6 is equivalent to 2 root of 2 open brackets 2 plus root of 3. That is the full form of the question that we have. So what is our goal? Our goal is to show that the left hand side is equivalent to the right hand side. Okay, so basically I'll start with the left hand side. We know it is equivalent to 4 over what? 4 over 2 root of 2 minus root of 6. So at this point, what we've seen on the other side is we don't have any denominator, so meaning that we're supposed to rationalize the denominator. So equally here we'll multiply by what we call the conjugate. So change the sign in between there. It will become what? 2 root of 2 plus root of 6. Then the same to be done to the numerator. Okay. What do we get to do in that case now? What do we get to do at that step? So we can now expand, simplify it further. So 4 by 2 is 8. So we have 8 root of 2. 4 by that, there is a 1 there, so it's just going to be a 4 root of 6. This is supposed to be divided by what? So we do the same. So when you're multiplying the conjugates, what we said is you get to just multiply the like parts. So 2 times 2 is a 4. Root of 2 by root of 2, I believe we now understand that it's going to be a 2. Then root of 6 by root of 6 is just going to be a 6. Okay, so at this stage what do we have? So I can erase that to just simplify it from there, continue from there. So now at this stage we can say our left hand side is now equivalent to, we have 8 root of 2 plus 4 root of 6 divided by what? So we are dividing by, so 4 by 2 is what? So 4 by 2 is 8, so minus 6, it's a 2. So we know it's a 2 there. I can even show it directly. So it's a 2. So we can factorize a 2 on top. So if you factorize a 2, you're going to remain with 4 root of 2. Then the other part, you factorize a 2, you remain with a 2 root of 6 over a 2. So the 2 can divide out and it will cancel out. So at this stage, what is remaining there? What is remaining is you have 4 root of 2 plus 2 root of 6. So we have to show that this is basically going to be equivalent to that part. So what have we seen that part? We've seen that what is actually outside is 2 root of 2, so I can factorize that as well. So what happens if we factorize? So we'll start with the coefficients. So on the first stage, where there's a 4, we factorize a 2, you are going to remain with a 2. Okay? Then you factorize the root of 2, there will just remain a 1, so you just have a 2 plus. The other part, you factorize a 2, so that 2 has come out, you just remain with a 1. Then you factorize the root of 2 out of root of 6. So this root of 6 is basically the same as 2 by 3, which is basically just like root of 2 root of 3. So you remove root of 2, you are going to remain with root of 3. And this is basically matching up with what you have on your right hand side. So you can even make a statement to say else shown. Okay, we are on the next question. Given that y is equal to 2x, express each of the following in terms of y to the power 2x. Okay, so for the sake of this was supposed to be to the power x. Okay, so given that our y is basically equivalent to the power x, we are expected to show some. Okay, so the first part they say we're supposed to express what we've been given in terms of y. So for our first part, what have they given us? They've given us that to the power 2x. Okay, so this is just trying to test our understanding on the issue of the indices. So whenever you have 2x here, it's basically the same as to the power x. So I want to express it in that form, so I'll say it's the same as to the power x. Then I've just factored out a 2 there. So then where there's 2 to the power x, I know that is y. So it's basically going to be y to the power 2. You've simplified the first one in terms of, you've expressed it in terms of y. You can now go back, you can go to the second question, which says 2 to the power x plus 3. So whenever you are having the powers being added, it simply means that basically you are multiplying same bases, then you get to add the powers. So that's what we have after expansion. So when we understand where there's 2 to the power x is basically it's equivalent to y. Then 2 to the power 3 is 8. So basically what we have there is what? Is 8y, the simplified form of expression. So we express it in terms of y. We can now move to the last one. We see the way it's going to come out. So we basically have 1 over 4. 4 is raised to the power what? 2x minus 1. So we want to express it in terms of the y. Remember what we are saying for our y is our y is basically equivalent to what? To the power x. That's what we know. So let's try to express it now. What do we get to have now? So we have 1 over. So we have 4 there. So whenever you're subtracting, it's an indication that basically what you had is you are dividing. So you have the same bases. So you have 4 the power 2x being divided by another 4 with the power 1. Okay. So what we have is kind of a reciprocal. So it's 1 over that. So we can just do away with a fraction by exchanging the denominator and the numerator. So basically the other way you can write that is like 4 divided by 4 to the power 2x over 4. So you can change your sign to multiplication by exchanging them. So if you swap them, it's going to be multiplied by 4 over 4 to the power 2x. And basically you're just going to have 4 on top and the 1 will disappear. So this is going to be equivalent to, so what we have is 1 over, also the 1 has disappeared, so you exchange. So you now have a 4 over 4 to the power 2x at that stage. So remember our y is in terms of 2. So we don't want to see a 4 down there. So 4 is the same as what? So we understand that 4 is the same as 2 to the power 2. So that is representing the 4. Then remember the 4 is also raised to the power 2x. So this is going to be equal to, so we now have 4 over what? So we can multiply this 2 by the 2x, is just going to be 4x there. So I want this to be in the form of 2 to the power x. So this is going to be 4, then we have 2 the power x raised to the power what? So if we can factor out a 4 from the power. Then at that stage, basically what we can say is we now have a 4 over what? So to the power x, we can put a y there. So we have a y to the power 4. So this is basically, in terms of 5, simplified form of that expression. And we've done it. Given that y is equal to 64, so in this case, the next part of the question, y is equal to 64, x to the power 6 divided by what? Divided by 25. This is what we have as our y. Okay? Then given that x, of course, should be greater than a 0 there, that is one condition that we've been given. So express each of the following in the form of kx to the power n. So that is the form that they want us to deal with in such a case. How do you go about it now? Given that k and n are constants. So the first part of the question says, I'll write it, y is raised to the power of negative 1 over 2. So remember our y, what you're saying is that our y is basically 64, x to the power 6 over 25. Then this is supposed to be raised to the power of 1 over 2. So we get to change the sign of the power by coming up with what we call a reciprocal. Okay, so what does reciprocal do? So the reciprocal just requires you to exchange, to swap the numerator and the denominator. So the reciprocal of 6 is 1 over 6. Okay, so the reciprocal of fractions, you exchange the numerator and the denominator, so it's 3 over 2. That's what you need to know there. So basically, when I have 6 to the power negative 1, this is basically the same as 1 over 6. They are equal, equivalent there. So since we have a negative power there, I can write the reciprocal and the power will become positive. So it's basically 25 over 64, x to the power 6. The power will become positive now. That's the way it works. Okay, so at that point, what can we do? We can now move. So the raising something to the power 1 over 2 is the same as the square root. So let me just try to show that a bit more. So we have the root of 25 over 64 to the power 64x to the power 6. That's what we have in such a case. So we can now distribute the square root. So it will be root of 25 over root of 64 root of x to the power 6. Okay, so the root of 25 is what? It's a 5. Root of 64 is 8. Root of x to the power 6. So what can you multiply it with to give you x to the power 6? It's x to the power 3 from the sides. You just get to add the powers. So I have x to the power 3. Alright, excuse me. So we are expected to express that in terms of the question says in terms of kx to the power n. So kx to the power, where k and n are constant. So in this case, we can say therefore it's going to be 5 over 8. Then we can take this one to the top because x is on top. Then the power becomes negative the moment you do that. So that's what we have as a simplified form of the first part. We've done that. We can move to the next question, which says now, in this case, I want you to say 25. So we have 25y. So this is all 25, then raise the power of 2 over 3, a fraction. So what do we get to do there? So our y, we understand that our y is basically that part, which is basically, I can show it, 64 x to the power 6 divided by 25. That's what we have inside the brackets here. Then this is supposed to be raised to the power of what? 2 over 3. So this is very easy because that can divide. Then inside the brackets, what we are going to remain with is just 24, or basically 64, x to the power 6. Then raised to the power of what? 2 over 3. So 64 is raised to the power 1. We can distribute the power there. So this is going to be 64 raised to the power of 2 over 3, and x to the power 6 also raised to the power of 2 over 3. Then at that stage, it's very easy. So whenever you have this part, this kind of an expression, if you want to understand it better, look at the cube roots. So the cube roots is when you have something like this. So this can also be written as 3 there, x. So it means that you've raised it to the power 1. Okay, so when you have 2 to the power 3, I'll put a 2 there, the power will also become 2. That's the way it works. So our 64 that we have in such a case, so we're going to have a 3 there, then it will be raised to the power 2. Then this 6 by that can divide, it's a 2, so I have x to the power 4. So this is another law of indices that I want you to know. I want you to know that when you have x raised to the power of a over b, this is basically equivalent to b, then x, then raised to the power a. Alright, so that is like what you need to remember. So what number can you multiply 3 times to give you 64? So basically it's a 4. So 4 to the power 2 multiplied by x to the power 4. So 4 to the power 2 is 16. So it's 16 x to the power 4. We've simplified it. Question B. Given that y is equal to, so this is basically again supposed to be to the power x. Given that y, so y is equal to the power x, show that 2 to that power minus that is equal to 0. So basically we want to show that this expression is basically equal to that. So what we have is we have 2 to the power 2 x plus 1 minus 17 the power 17 multiplied by 2 the power x plus 8 is equal to 0. So our goal is to show that this is going to be equal to 2y squared minus 17y plus 8. That's what we want to show, that expression there. So given that y is equal to that, so we want to make sure that in this equation we get to substitute y. So what we'll do, what are we going to do? So what did we say? The first point that we made is whenever you have powers being added, it simply means that you add numbers multiplying of a same base. So it's 2 to the power 2x being multiplied by 2 to the power 1. Okay? Then you just added the powers for us of that. Minus 17. Then 2 to the power x. So these other things are just direct. So 2 to the power 2x, basically we want it to appear in the form of y, meaning that we need to have just 2 to the power x. So I can start with a 2 there. Then 2 to the power 2x is the same as 2 to the power x. Then I'll factor out a 2 minus 17 to the power x plus 8. So you've seen that I've come up with, at every part, every component, at least now we have 2 to the power x, and we can now plug in. So what do we have? So where there's 2x, I'll put y. So we now have 2 y squared minus that part, I put y as well. So we've shown. That's very easy to show. It's just applying the laws of indices. Then the second part of the question says solve. So we're trying to solve now. So this is a quadratic function that you can do with. So let's try to see if factorization method can work. So the product of 2 and 8 is what? Is 16. The summation is what? Negative 17. What numbers can we multiply to give us 16? We had them, they give us 17. It's basically negative 1 and negative 16. So we have 2y squared minus 16y minus y plus 8 is equal to 0. So the factors gets to substitute the middle part. So if you don't know that, check out my video on factorization. Okay. So at that stage, what do we get to do? How do we get to approach it now? So we have to factorize what is common. So group these. So the first part, what is common is 2y. In the brackets, we remain with y minus 8. Then the other part, we want it to appear as it is in the other case. So factorize the negative 1. Then we have y minus 8 being equal to 0. Then at that stage, we can group them. So we have 2y minus 1. I've gotten this and that. Then we also have y minus 8 being equal to 0. So at that point, we are able to find the values of y. So you can work with any method. If you want, you can work with a quadratic formula. You still get to a solution. Okay, so that is 2y. So 2y minus 1 is equal to 0. So in that case, 2y is equal to 1. Y is equal to 1 over 2. Then the other part, y is equal to 8. So we have our values of, we've simplified it now. So let's try to find the values of x now. So for the first part, what do we know? We know that our y is equal to 1 over 2. So our y, basically, from the start of the question, we are told it's equal to 2 to the power x. So for the first part of our y, we are saying it's 1 over 2. It's equal to 2 to the power x. Okay. So our goal is to make sure that we have the same bases. So 1 over 2 is the same as 2 to the power negative 1 equal to 2 to the power x. So in such a case, our x value is what? Is equal to negative 1 for the first part. Then for the second part, where our y is equal to 8, we equate it to 2 to the power x again. So 8 is the same as 2 to the power 3. So the bases are the same, so therefore x can also be equal to 3. So we've solved this question. The last question says, use algebra to solve the simultaneous equations. So there are different methods that you can get to work with. Okay. So the simplified method that I can work with is by looking at the second equation. So if you look at the second equation, what we have is x squared plus x plus y squared. So in this case, I'll use substitution methods as the simplest method to work with. So I can make x to be the subject. So if I make x to be a subject, what happens? Is it possible to make x a subject? It's basically not possible. So to simplify my life or my work, let me look at the first equation. So we have x plus y there is equal to 5. So in such a case, I can make x to be a subject. So x is going to be 5 minus y. So having done that, I can go to the second equation now. Where there is x, I can plug in that. So I'll start with x squared. So where there is x squared, I'll put 5 minus y squared. Then where there is x, I'll just put 5 minus y, because it has x, plus y squared is equal to 51. So expanding this, 5 times 5 is 25. 5 times minus y is minus 5, so it will come twice, it will be minus 10y plus y squared. So that is how you expand that. If you want, you can expand the brackets and get to do the multiplication. You get to that result. So we have plus 5 minus y plus y squared is equal to 51. Do we have like terms there? So y squared plus y squared is 2y squared. Negative 10y minus y is minus 11y. 25 plus 5 is 30. That one can come the other side, it will be minus 51 equal to 0. So this is kindly becoming what? It turns out to be coming out as a quadratic function. So you have 2y squared minus 11y. Then 30 minus 51. What's the difference there? It's minus 21 equal to 0. Okay, so what method is basically going to be applicable when it comes to dealing with this question? If you look at the products here, our product is going to be 42, negative 42. Our sum is negative 11. Are there any numbers that you can deal with there? What numbers can you multiply to give you 42? It's obviously 21, right? 21 and what? 21 and 2. But that can give us a sum of that. How about 7 and 4? 7 and 4. 7 plus 4 is 11. Okay? So want a negative value. So 7 by 4. 7 by 4 is what? 7 multiplied by 4 is 28, which turns out not to give us the required result. So we can work with quadratic formula. So we know that our y is going to be equal to negative b plus or minus the root of b squared minus 4ac divided by 2a. Our b in this case is 11. So we can begin substituting. So where there's b, I'll put negative 11. Okay, so negative 11. Then where there's b squared, again I'll put negative 11. Then where is our a? I'll put our 2. Then our c is 21. Then where is our a again on the denominator part? I'll put our a, which is a 2. Okay. So what do we get to do from that stage here? So I have 11 plus or minus. 11 by 11 is what? So we're looking at 11 squared. So basically it should be 121. So 11 squared is 121. So you have 121 minus 4 times 2 is 8. 8 times 21 is what? 168. So it's a positive value because of a negative and the negative. 121 plus 68. So 121 plus 168 divided by 4. So I have 11 plus or minus. So 121 plus 168 is 289. What is the root of 289? It's basically a 17 over a 4. So basically what was coming out there is a y. So y is going to have about 2 values here. So the first value is going to be 11 minus 17 over 4. Then the other value is going to be 11 plus 17 over a 4. So 11 minus 17 is what? 11 minus 17 is a 6, a minus 6 by the way. So negative 6 over 4. Then 11 plus 17 is what? 11 plus 17 is 28. So therefore our two possible values of y is, the first one, negative 6 over 4 is the same as what? Divide by 2, it's negative 3 over 2. Then the other value, 28 divided by 4, is a 7. So these are the two possible values of what? Y. So using these two values of y, we're able to find the other two values of. So I'll say, okay, when my y is basically equivalent to negative 3 over 2, I'll go to the first equation. So where there is x, I don't know. Where there is y, I'll put minus 3 over 2. This should be equal to 5. So x is equal to 5 plus 3 over 2. Then as we get to 5 multiplied by 2 is 10, plus 3 there is 13. That's our these are possible sets of values. Then when y is equal to 7, x plus y, x plus 7 is equal to 5. X is going to be 5 minus 7, which is going to be a minus 2. So we've solved these simultaneous equations we found. So whenever you can see a quadratic there in the question, it's basically there are two possibilities of a solution. Sure, there are two possible solutions, set of solutions, and that's what we've done. So that's it for this video. Check out the other video that will continue with more questions on algebra. Thank you very much. UNILUS.